Thank you all for joining the April 30th SIMBA Chain webinar. This is a special webinar for a number of reasons. I think, first of all, we have Dr. Ian Taylor, our CTO and co-founder, is here. I know that on the initial invite, Vice President of Engineering Andrew Harrison was going to be the special guest. He's not able to make it. He's perfectly fine. He's just very, very busy and had some other commitments. But he's alive, healthy, and well, so no worries there. So in his stead, we have our CTO, Dr. Ian Taylor, and so that is a great treat for all of us here and all of our attendees. We don't get to hear from Dr. Taylor all that often because he's very busy working. So this is a treat. So he is literally one of the most cited academics in the world on blockchain. So it's great to always get his thoughts on and his wisdom on this. So also, we're in a very say a difficult time in the history of frankly of our world, and humanity, with with COVID-19 and the coronavirus, and so many of you out there and so many of us here now social distancing or some form of distress, and we do hope that you are all okay and that your loved ones are okay and your professional colleagues are okay and staying healthy. And so given the options that are out there, we appreciate your attendance here on this webinar. And we do feel that, what SIMBA Chain and blockchain has to offer is first, it's training that let's spend this time to get our skills up so that when things normalize, we'll be in a better position to, in our personal and professional lives. I also think it's important to note that, if you look at some of the fallout from this crisis, we're in the early stages of kind of recognition within even the blockchain industry of how blockchain can really play a role in building a society that is more resilient. Whether that be around the importance of transparency, the importance of having less fragility and more resilience in, say, our supply chains, the importance of data sharing, the importance of collaboration, because we are, whether we like it or not, interdependent and connected, clearly, as this crisis has shown, and on and on and on. And through all of those, blockchain has a role to play and could have a role in some of those cases more than others, and even in public health. And so I think it's important that, some of the trends towards kind of the fourth industrial revolution that we talk about with blockchain and the new stack with our AI and IoT and cloud, many of those trends may accelerate. We're already seeing it in streaming. We're seeing it now in the importance of supply chain resiliency, where blockchain can play a role. So it is possible, even probable, that some of those trends will accelerate because of this crisis, and that more of our colleagues and our friends and in our professional and social circles will begin to realize where blockchain can play a critical role. So with all that, that's all I'm going to say for now. I'm going to hand things over to our master trainer, Tommy Cooksey, and for those of you from our previous webinars, you know him well. And he's going to give us an overview of SIMBA Chain and walk through the tool, and then we're going to hand things off to Dr. Taylor. We're going to leave the last 15 minutes for Q&A, but we will take questions that might be highly contextual and relevant, peppered throughout the presentation. But most of our questions we will handle at the last 15 minutes. So with that, Tommy, please take it away.
All right, great. Hopefully everybody can hear me okay. So let's go ahead and get started. Thanks, Anjon. Anjon, that was an amazing introduction. So as we probably remember from the first webinar, we mentioned that SIMBA Chain did stand for Simpler Blockchain Applications. Talked a little bit about our history, and one of the important things that we want to kind of stress again is that our goal is just to make that heavy lifting, all that work you have to do in order to be able to retrofit maybe what you're already doing with blockchain, right? So webinar, and then also kind of take a look how kind of could easily be retrofitted maybe with an Azure Workbench solution. So rapid blockchain applications, being able to go to proof of concept in just a few days or maybe a few hours or a couple of weeks, but not months or years, right? And so in today's day and age, obviously, we can see lots of workloads where that's going to be a necessity. So when we start looking at our business process, we can start to have realization of where within that business process we might want to start to put in a smart contract. We're going to generate a REST API so that we can then have certain data that will be put on chain to give us provenance of that data, and give us insight of what was going on with those state changes that may have occurred with that data. And then we have off-chain data that, of course, could keep privacy and things like that. So we talked a little bit about that in our last discussion. But again, one of the important things that we want to remember is that when we mitigate trust, using data, we almost always do it with cryptography. And one of the great things about blockchains, and especially when we start dealing with smart contracts, we can start baking the cryptography into the code. So that's pretty amazing. So again, another big thing that we talked about in the last discussion, just to kind of review with everyone, is we wanted to kind of give you an idea to understand where your workflows might get interrupted. And we wanted to talk about specifically where the blockchain is going to fit, right? So where are you going to be actually using this distributed ledger that everybody's talking about, whether it be a public blockchain or whether it be a hyperledger solution that's more of a private blockchain solution. So we support both of those. So one of the nice things is that we have a data set, traditionally on the back end that we were putting in that relational database. And so one of the things that we want to remember is that we're moving a lot of that data away from that traditional database, and a lot of that data is going to be ephemeral data, more structural type data that defines that, how the transaction is going to occur. And then we have content that's going to be going inside of that structure, and that's going to be more persistent. And so that persistent data, sometimes it may be in the database, but a lot of times that transactional data, we want to put it into an immutable ledger. We want it to be distributed data that is available through a network of authorities. And so that could be public authorities or it could be permissioned authorities. And so when we think of all of the various different attributes that a blockchain gives to us, I just like to remind us that, a lot of these attributes are traditional attributes that we weren't able to get in a traditional networking solution. So with a blockchain, we can have things like a distributed immutable ledger, right? A distributed immutable ledger of cryptographical data that has an anonymity built into it that also has transparency in the ledger. So we can kind of read and do transactions. So I use this little acronym here, DI-CAT, in order to kind of remember that those attributes are things that traditionally it's really tough to get, but now with a blockchain you can kind of get that kind of hardness in your network or in your solution. So when we start thinking about that transactional data, there's a lot of value in that transactional data, and that's where we're going to try to put that onto the blockchain. So we're going to be looking at assets and transactions. Assets are our nouns, transactions are our verbs. Think of state changes. Anytime that you're making a change to state, then it's probably something that you're going to be building it out. You're going to be putting that into your smart contract. And so we're going to build out a smart contract, show you how to build it out real easy, show you how to also tie some of that data maybe to some off-chain storage. Maybe you want to put that into your Azure Blob Store, maybe in an S3 bucket. Maybe you want to just get an IPFS endpoint where you can distribute that through an IPFS endpoint and still have a completely distributed application. So that's possible too. So we're going to show you all these options, and we're going to show you how to build a smart contract, deploy it, and build an application on top of it. So one of the things that we will be expecting that the application has the capability of doing is the ability to have data that is not necessarily on-chain, but is what we would consider off-chain data. And so off-chain data, as we had mentioned probably before in the first discussion, is that's where we're just taking that data, putting it into a hash, running it through a hashing algorithm, putting that thumbprint on chain. And then what that's doing is it's giving us basically a hashed index. And then we can reference that hashed index for the state of that asset at that particular time. So we can kind of understand state changes and things like that. And so that's what we're showing here in basically what we're doing with that bundle hash. So we're going to show you how to build that out as well. So let's go ahead and get started. Let's check this out. We're kind of walking through all these slides, but we really want to see so let's go out here, and if we go out to to get started, we're going to go out to app.simbachain.com. And I've already created an account in the last demo. We talked a little bit about managing your wallet and all that functionality. So we're not going to go through that again. But we are going to do is we're going to go down here and we're going to go ahead and talk through actually building out a smart contract. And so one of the nice things is that when you want to build out your smart contract, you can just come down here very easily. You can generate your smart contract. So there's a couple we're going to be looking at. The first one we're going to look at here today is going to be one that probably all of us can kind of relate to, would be just a simple shopping list. And so if we want to go ahead and look at maybe what that workflow might look like, we can easily see that when we use this template here that allows us to add an asset. So I can just come in here and I can add an asset like, you know, a shipment. And then once I create that shipment, then I can go ahead and create relationships between various things with that shipment. So whenever you create either an asset or a transaction within your workflow, you can go in and then define additional data primitives on that asset. So just basically as if you were doing object-oriented programming, you're going to go in here and you can define the parameters, for instance, of your grocery item. And you can say, is this grocery item a gift? What type of grocery item is it? What variety is it? How many are you going to get? And then the interesting thing that you'll notice here is we have this thing called a bundle hash. Well, that we're saying is a string, and that means that we're going to tie this to off-chain data. So this is going to be a storage area that you're going to create an endpoint in your application that you're going to use to interact with your smart contract. And so it's going to generate the REST API for you to have that off-chain data. So the bundle hash that you see here is that hashed index that I kind of mentioned earlier that points back to the inputs that you sent through the SHA-256 algorithm that you're using as that basically that thumbprint of whatever that data set is at that particular point in time. So that's what we're doing here, and we can do this again. We can do this for all these various different transactions, and we can do this for all of the various different objects that we have as those objects have various different state changes to them as the transactions occur. So when we look at these parameters, we can see that all this stuff was very easy to build out, and the goal is we're trying to just merge that gap, right, between that business professional and the developer. Because the business professional is going to understand this. The business professional is going to be able to look at this workflow and build out a pretty complicated workflow. I mean, mom can build this workflow out. And then, you know, if we want to get something a little more complicated, let's go ahead and just leave this and go into our cost insurance freight. And when we look at this, we can see that, you know, this is actually dealing with a pretty complicated shipping algorithm and shipping workflow that has a lot of different players involved, where the data that is being used by those players needs to be timely, needs to be accurate, and needs to be effective, and it needs to be, you know, we need to have provenance in it. And so, so now we can easily build out that workflow as a business professional, and then behind the scenes, what's happening is the code is being generated for you. So do you still need to have maybe one or two coders on staff that are going to be able to write Solidity code and understand how to set up an Infura node and how to do the things that might be required in order to support a full decentralized portion of your application? Possibly, but we also have bring your own blockchain. So if you want us to manage that for you or run that as a managed service, we can do that. But if you just want to build out a proof of concept, you can get a proof of concept built with really not having to learn too much code. So all of your Solidity code is still here for you. It generates all this code for you. You don't have to write any code. And then the nice thing about it is once you're done with that, you know, and building out your smart contract, now you're ready, you can go ahead and layer an application on top of it. So when we come up here, what we'll find is if I go in and create a new application, it's just going to say, okay, well, you're going to build a new application. What are you going to be building it on top of in the back end? So what's your blockchain app? So we're going to build it on an Ethereum app. So let's just select Ethereum here. And then we'll select that we're going to build this on the Circle of Life, which is the the internal private blockchain provided to you as a sandbox by SIMBA chain. And then we'll go ahead and put our off-chain file on a Ceph volume, maybe in an Azure Blob store. And so we'll go ahead and select that guy, maybe. All right, well, maybe we'll just do IPFS. There we go. And then it's going to ask me which smart contract do I want to use. And so I'm going to go ahead and select that I want to create a smart contract based on that shopping list that we were just looking at. And then we'll just put in here list for home. And so what is this doing is it's telling us that this is going to be the API that's going to automatically get generated so that we can use this endpoint, this REST-based endpoint, to go ahead and interact with this smart contract as long as we have the appropriate API keys. That's pretty amazing, right? So now when I go in and I click OK, I have to pay for it since this is going to be an Ethereum smart contract. So we've already funded our Circle of Life wallet. I just need to unlock it. So remember that, you know, one of the nice things that we like about blockchains is that we get rid of the CRUD database, right? We get rid of the updates and the deletes. We just have creates and reads. So we got to pay for all the creates. So we had to pay for those. As it went, what happened there is it went in and it said it paid for the transaction. It generated the transaction. It generated the smart contract. It wrote the smart contract. Oh, and also it built out a front end on the front end for you as well. And it built out a front end that you can use as a developer. So holy cow, that was amazing. Let's go out and check that out. So if we come in and take a look, we can see now that here, this one's still kind of being built out, this list for home. But I went ahead and I built one of these out this morning. So let's go ahead and just look at the one that we did from this morning. So I have this shop one, 1345. And so the first thing that we're going to look at is we're going to look at our ability to interact with this if I'm the business professional. So if I'm the business pro, I'm probably going to just want to come in and deal with all the methods that are going to be exposed by this smart contract. So I want to be able to do that probably through some web interface because I'm not a programmer. I just want to go in and do that as a business pro. So that's really what you'll find here with the method calls is it kind of builds out. You still have to unlock your wallet. So you got to pay for, you know, all your transactions if you're going to be writing transactions to the blockchain. So anyway, so that's what you did there, and then you got to, you know, tell it which wallet you're going to use, and then here, as you can see, you can interact with this smart contract. So I can go in and I can say, hey, I bought this item in the store, make a call to smart contract, actually interact with smart contract directly as a business pro right here, pretty easy and pretty simple. And then I can see what's happening with this smart contract over on the right hand side. And so you know, one of the nice things is you know, if you really want to get into the tech details, you can go into this more info and you can see like here, you know, on this here, let's see, what did I put in? I got some milk. I got 12 pints of milk, and it was a dairy variety, right? And so so that was an input where we wrote that to the blockchain, right? And so when that happened, that was exposed and that was created very easy and very simply. And so these are all the transactions that I did, you know, here this morning. And so, you know, you can also go all the way down to the individual transaction where we deployed the contract itself. And so what you'll notice here is this is actually the bytecode that got, you know, that smart contract got compiled down to how much gas was used. And you see that for every transaction that's being sent to this application that you've created. And so when you go back to the application itself, and we actually look at it, so here's the one that we were just building, and we were just talking about the method calls. If we look at that from a method call perspective, that's great for the business pro. But as a developer, that's really not what you're going to want to use. You're going to want to code this, and you're going to want to code it using, you know, API keys and stuff like that. So how do you set up your API keys, and then how do you interact with these functions that have been exposed to us? So one of the things that we can do is we can come in here and we can just set up these API keys very simply and very easily. I can just come in and generate new API keys. And so API keys for demo. And so once I generate those keys, then I can go ahead and use those in my application. So when I go in here to my my API, you'll notice here that this is actually the REST-based API that got exposed based on all the method calls that you created in your smart contract. So here, first thing I got to do is I just got to go ahead and authorize this, this web interface with the API key. So let me just go ahead and put that in there. It's the API key I just generated. So I did that, and so now I can go ahead and I can do the GET request against this smart contract, or if I want to go ahead and do a post or whatever, I can do all of my puts and gets against that and interact with that smart contract and see, what's happening. So for instance, if I want to create a new transaction and I want to say, hey, let's see here. Oh wait, hold on. That's for the transaction options. So here, if I want to go in and say I bought a new item in the store, where did I buy it from? So when I say where did it get bought from, I'll need to put in an address. So let me go ahead and put an address in here for you. And then our API key that we just generated would be the API keys that we were just talking about. So we'll have to put that in there. And then date and time, we just said that's going to be a Unix epoch date timestamp. So let's just get whatever right now. So there we go. So we can just throw that in there. And then grocery item, what do we buy? Let's buy some, I don't know, let's buy some. And so then when we go ahead and run that, we execute that, we'll go ahead and you'll notice that it just goes ahead and generates our curl request, which does the post out to that HTTP endpoint. It goes ahead and throws in all the parameters that we put in there right there. It generates that curl request for us. And then here's our response code. So we got a 200 response code, which was success, and that's what we got back, right? And so if we wanted to kind of start building out on top of this, building out our front end on top of this, it's very, very easy for us to interact from a development perspective. So again, the ability, for you to kind of bridge that gap between the developer and the business pro is the goal. And so it makes it really easy to remove a lot of ambiguity that happens, as we try to make that exchange of information and try to understand how these business processes are supposed to work. So we believe that with SIMBA Chain's tools, you're going to be able to remove a massive amount of workloads, a massive amount of steps that might be involved in your workloads just by doing multiple iterations, trying to get it right. So, anyway, so that's generally speaking about how the app works. Now, one of the other things I want to show you here is if I go into the application, and we've seen the API, we've seen the API keys, we've seen the method calls. We can also look at our transaction logs, which of course would show us all the transactions that have occurred with that smart contract since its inception. And then we can also go into the information about this application itself. So here we can see, kind of how much data, what kind of metadata have we generated on this particular application. So what blockchain did we roll it out on? What was the, the name of the application? What smart contract was it created upon? And then here we have this thing called a bootstrap config key. And that key is actually something that then also can be leveraged within Azure, and that's what the illustrious Dr. Ian Taylor is going to be helping us with today, is going to show us a little bit about how the Azure Workbench works. And so with no further ado, I want to probably going to hand it off to Dr. Taylor. But with that being said, I did kind of mention, you know, some of those things that we want to look to. What are the features in a blockchain that we look to add to our existing workloads? And I kind of mentioned that those are things like decentralization, right? Immutability, cryptographic data, anonymity, and transparency. So if you need those things in your workload, then you probably want a blockchain. There's something in a blockchain you probably want. So I call that DI-CAT. But with that being said, if you want to remember that, you can just remember that Dr. Ian cares about transactions. So with nothing further ado, that's my introduction to Dr.
Taylor. Okay, thanks, Tom.
You bet.
Can you hear me okay?
Yes,
Yeah,
we can.
okay.
Hey, Dr. Taylor, before you continue, this is Anjon again. Had a couple questions I wanted to throw out there. We have one question: is it only for Solidity and Ethereum? And the answer is we are protocol agnostic, both structurally as well as strategically. We support several protocols, and that number is rising. Is rising continuously. So at the moment, we support Quorum, we support Ethereum, we support Stellar, we support RSK, which is the side chain of Bitcoin for smart contracts, if you want to use that protocol. And in short order, we'll be supporting Hyperledger. And so, and if there's any things you want to add to that in terms of coding and Solidity, please do feel free to add either of you. Another question is, will SIMBA chain be handling smart contracts and API endpoints? And the answer is yes, but feel free to elaborate on that.
So smart contract endpoints meaning different versions. So yeah, let me touch on that now. So got a couple of slides here just to introduce. So let me just move this out of my way. Okay, so there's two environments. Tommy just showed the first environment, which is the app.simbachain.com. That right now enables you to build apps using our smart contract designer, which Tommy demonstrated, and deploy them, which was also demonstrated. Tommy kind of passed it over to me with this API key. I'm going to show you how that API key is used to import smart contracts into this SCaaS environment. Now this SCaaS environment is a completely different implementation. It's actually, it doesn't really have a common code base with the SimbaChain.com. SimbaChain.com was is designed to work with public blockchains essentially. Our smart contract as a service is designed much more at the enterprise and contains a number of different features that are not available on .com. So let me just go through to the next slide. One of which we pay a lot of attention in the SCaaS to fault tolerance. So this is just kind of showing the process. So you go from a SimbaChain smart contract into the enterprise, and the enterprise kind of looks like this. And this just shows a schematic of how transactions are dealt with. So when an application posts a transaction to the HTTP API, which is Tommy showed you that through the Swagger interface, that's actually put into an asynchronous queue, and that is transacted onto the blockchain. So you can have multiple, the underlying blockchain we're connecting to in this implementation that I'm showing today is the Microsoft Azure blockchain service. So that's Quorum. That's capable of several thousand transactions a second. So this queue is meant to kind of, load balance that essentially. So the queue kicks off a bunch of workers that each worker transacts on the blockchain, and it waits. So it kicks off a task called a chain watcher. The chain watcher monitors those transactions, and when the transaction is completed, it changes state. And I'm going to show you what that looks like in the app. Once that state is changed, it is cached in a database. And that cached in a database serves a couple of purposes. Primarily, it's for caching transactions for searches. So when we're doing searches, that you can optionally choose to go right back to the chain if you want, but obviously that's going to take longer, or you can use the cache, and the cache is instantaneous. It's essentially a Postgres database, and we're just querying that. And then additionally, onto that second question that was asked in terms of smart contracts, within this database, we we store, and on the blockchain actually, we store links between smart contracts. And we've got our new version of SCaaS that we're just about getting ready to release, has a GraphQL implementation overlaying that. So what that means is you can have multiple versions of a smart contract, and when you query the latest version of that smart contract, it knows about all of the previous versions. So when you query that, we do a best efforts basis to retrieve all of the transactions from all previous versions of that smart contract. And additionally to that, we can even do that across chains. So you could have transactions on one blockchain that you've deployed, and we can link that across to another blockchain and retrieve all those transactions. So that's some of the things that are coming up, and I hope that answers the question. But it makes it possible to manage these smart contracts as multiple versions come across. And then these are some of the services that we have. So we use Azure. This is the implementation in Azure. The SCaaS is actually implementation kind of agnostic at the basis. All of these services are written in a pretty generic way. And then our binding to Azure uses the native Azure services in order to be completely elastic in every direction. So we use the Azure app service to host the actual SCaaS itself, Active Directory, full Active Directory integration. And that actually includes when you integrate an app using an Active Directory existing application, you can have SCaaS auto-generate the wallets for your users on the back end, and that's stored in the Azure Key Vault. So essentially, when a user comes into the system, which you've added a new blockchain backend onto, when they transact and that user transacts on the blockchain, we also generate a smart wallet, and that is used to sign smart contracts. There's an identifiable kind of path back to that user, but the user doesn't have to go through the process of managing those keys. The application can also generate, store the keys or have the keys pushed back to the user, as we do in app.simbachain.com too. And then we have the service bus implementation, which does the asynchronous, transactions to kind of buffer on the way in. And we also use, for off-chaining, we use the Azure Blob storage. And then the cache, we use Postgres, and then the Azure blockchain chain is the underlying blockchain service. So let me break out of that and kind of take you through a demo. So this demo, I thought it'd be kind of fun. So we have this Basecamp. This is basically using a smart contract that we generated on simbachain.com. It just allows you to register STL files, which are 3D, you can use to make 3D components, so print 3D components rather. So we have a SIMBA chain coin here. If I try and wiggle that, it doesn't work, but if I download it, it's downloading the STL file into the browser, and then I can move it around. So what I'm going to do is use the CIF, which is the cost insurance freight example that Tommy mentioned in his talk, which I can show you here. So this is the smart contract CIF here. So this is this one, okay? And this kicks off with a purchase order, and it basically, the purchase order goes across, a supplier in another country, and this, there's various kind of players involved in this complex scenario. So what I'm going to show you is how to create a purchase order, and just for fun, we're going to order 2,500 of these SIMBA chain coins from a company in Singapore. So let me show you what that looks like. This is the CF demo. Let me pull an old school file up. So this was what the purchase order looks like. We have SIMBA chain sending an invoice, or sending a PO to this Widgets Global in Singapore. And we want, actually 10,000 of those at $10, so a $100,000 order. And what we're going to do is we're going to pass the instructions, and we're going to pass the IPFS hash of that actual coin, which is from this number here. And that will, once they receive that, not only will they receive an order that is secured by the blockchain all the way across, they also receive the identifier so that they can download this STL file and ensure that they're printing the right version that we have ordered. So that kind of all ties across. So this is what the a Word version of this order looks like. But what we're going to use is we're going to use an EDI file. So EDI is electronic data interchange. It's a common standard. This is what it looks like. That's the same information in the other, in the other order, except that there's a lot of stars and various things to do with EDI that you have to sort of conform with in order to do an EDI transaction. And then this is just the STL file here that we're sending. Just a copy of that. So this is some chain. Okay, so let's go into the SCaaS and let's have a look how you do that. Initially, let me show you quickly. I'm just conscious of time here, but let me show you what this kind of looks like. So the CIF demo here has this bootstrap key. So if I copy that, what I can do is I can go into Azure and I can go into the SCaaS. This is Smart Contract as a Service, and I can pull up a SIMBA Explorer. And this gives me access to multiple smart contracts. So I can manage as many smart contracts as I want here. And I've already got a couple of CIF instances that I've imported, but just to demonstrate how that works, you paste in your bootstrap key, demo for webinar. CIF. Let's add that. So what's going on there is this is making a request to app.simbachain.com, and it's asking, it's requesting that using that bootstrap code, it's requesting that smart contract be imported into this environment. So what actually happened there was we downloaded the smart contract, we compiled the smart contract, and we deployed it on Quorum. And as you can see, it just took a few seconds. This is our smart contract within this environment here. Obviously, it doesn't have any transactions right now. We just deployed it. But what we can do is we can, let's put a transaction on there. So the way we do that is we'll go back to, sorry, wrong button, welcome page. Let's go down to see the smart contract APIs. Now, when I go into this page, I can't do anything here except for view until I authorize. So this is the Azure environment. So I have to go in here. I have to click this SCaaS access here and authorize. That goes off and tells me to log in. I log in and then I come back and now I'm authorized. So now I have a bearer token for Microsoft Online that allows me to make transactions on this smart contract. Well, actually on this version of SCaaS. So let's go down to the new smart contract. So this is the same as what you would have on here on a deployed version of this. Here, let's just go to that. So it's pretty much kind of identical. The versions of Swaggers are slightly different, but the smart contract is it has the same kind of endpoints. We're just upgrading this in the new version to make it absolutely identical. But now we have all of these different these different endpoints to play with. So let's look at the purchase order. So what I'm going to do is try and create a purchase order. So let me try it out. So to try it out, I just need 3 parameters. So I'm going to say the buyer is SIMBA. The date time, I'm going to do the date plus %s to get the latest Unix time from the command line there. And then for the EDI transaction, there's a weird format here that you need to follow for these. They're in this format. I'm just going to copy this across into, wrong version, close that, it's confusing. And I'm going to paste that into here and execute that. So that's going off and doing the same that Tommy showed. It does a curl request to that endpoint with these parameters, and that's come back with a 200 request, which means success. Now, if I go back to the SIMBA Explorer and I look at these transactions here, I can see this transaction here, which has no details, and that is because it has been submitted. So remember in this flow that I showed you earlier here, it's at this point, it's in the queue, it's been transacted to the blockchain, but it's in the mempool essentially for that blockchain. It hasn't actually been put into a block yet. So the chain watcher is listening to that transaction now, and if we load it again, that's been completed. So it didn't take very long, but once it's been completed, you can look at that and you can look at the transaction. So this is the transaction, SIMBA with that timestamp and this ST number here. Okay, so that was a simple transaction. So let's do something more complicated. And what I'm going to do, I'm going to do a subscription to this this smart contract. So for demo webinar, I'm going to look at the purchase order and I'm going to add a subscription. Let me copy this across because if I type it in wrong, it would just fail, of course, because the wrong email address. Let me have a look here. So So I'm going to send, there's two ways of doing subscription. You can do an email, or you can do a web endpoint, an endpoint to trigger another application. So I'm going to do an email. I'm going to send to this email address. I'm going to subscribe on a purchase order. And on the purchase order, I have 3 parameters that I've defined in my payload: date, time, EDI, as I just showed you. So I'm going to say, okay, I want to look for transactions where the EDI number equals, and then let's get an ST code here and put that in here. So, but let's do, I don't know, 88 or something. And I'll copy that so I can do that. So let's add that and then subscribe. So what that's done now is I've got a subscription on that endpoint. Just listen to that endpoint. That should email me when the EDI 850 code is equal to this. So let's go ahead and make a transaction to that effect. So this time, instead of doing a simple transaction, I'm going to attach the data. I want to send the purchase order and the EDI along with my transaction. So I'm going to do SIMBA as the buyer. The EDI transaction I'm going to put as 88. So I can be, because I've set up my subscription for that. The date, time, let's get another one of those, just to be accurate there. And then let's load in a few files. So I'm going to send 2 things. I'm going to send the actual, PDF of the order, and then I'm also going to send the EDI. So this is kind of old school meets new school, I suppose. And those, you can add as many files as you want here. So when we execute that, what that's going to do, it's going to go off, make a transaction, but it's going to off-chain these 2 files here into Azure Blob storage, and then it's going to wrap those up and essentially, and we can see what that looks like actually, because let me go back to here. So I'm going to go back to the Explorer, and we've got another transaction which has been submitted there but hasn't completed. So we need to wait for that to complete. But that once that's completed, what we'll be able to do is look at that transaction, and we'll be able to go into the transaction and load the manifest file, which is the file that's put into blob storage that describes all of the files that were attached. And then we can go into each of those files and download them all as a zip file. So that has been completed now. So if you look here, this is the status of the transaction. Now, if I go down to the smart contracts down here and look at the purchase order, I will see this transaction, and there's an attachment to this transaction. Now, if I look at that, this is what our manifest format looks like. This is basically a simple JSON file, which is stored, that references all of the different file names. So you can see here, it's got 2 files. It's got the SIMBA PO example PDF with the hash code of that. So we have a non-reputable track of exactly what that SIMBA PO example.pdf was when it was stored bit by bit, because if the one single bit on that file changes and the hash code changes. So this has and this is recorded on the blockchain. The hash of the manifest is stored on the blockchain, which contains these hashes. So you have immutability through that chain for this. Well, you have what was stored, and if it changes, if it's changed. And then you also have this EDI file. So if I download that to my desktop and take a look at what that looks like, and go into this directory, then what we can see is the 2 files that were attached to that order, which I just showed you. So that kind of gives a brief overview of this. We wanted to leave time for questions, so I think that's just about right. So we have about 15 minutes left. So I'll hand it back to the floor and see what questions we have.
Thank you, Dr. Taylor. That was a great whirlwind tour of a taste of what we can do in our enterprise offering that SIMBA Platform can do in the Microsoft Azure enterprise offering. So please do not be shy for those of you out there who want to ask questions. And in fact, we do have a backlog of questions. So I will start with the backlog. One of them we did, Redeem's question on handling API endpoints. I believe you did answer that. Mark asked, is there a difference in your support for private and public blockchains? And I think the answer is we support both. With our SaaS offering, focused more on the public side, particularly with Ethereum, though you can publish to private as well. But with our enterprise offering, really focused on the private blockchain, so you can go in either direction. But would you care to elaborate any further than that?
Yeah, I'm a bit lost on the questions, but yeah. So we essentially the SCaaS environment is you know, supports private blockchains. On app.simbachain.com, we do have, you know, our Circle of Life is a private blockchain, but that platform is more oriented towards public blockchains. To really, in the enterprise, you know, I showed you how this connects to Quorum, but we have multiple you know, implementations there. We have within that same environment, we're just about getting ready to deploy a version of Fabric, Hyperledger Fabric. And the way we've integrated the Hyperledger Burrow EVM into that and connected that to our tooling, and that's working really nicely. And we're deploying that probably onto a kind of a VMware you know, installation into Naviair actually. So it's pretty flexible, and we can plug in, you know, the Hyperledger Burrow integration took a little bit longer because we had to integrate Burrow with Fabric, and then we had to kind of integrate that through to our backend adapters, but the adapters kind of support, you know, it's very easy to kind of integrate them. We did RSK in a day, for example, so it's quite easy. We're just, you know, we're strategically kind of bringing those in as and when customers kind of request them. Maybe it's easier if I go through these questions here. Is it only for Solidity Ethereum? No, so we have, you know, most of our enterprise, well, our integrations are Ethereum based, it's true, but we also integrated using to Stellar, and Stellar is completely orthogonal kind of implementation, you know, whereas Ethereum provides the smart contract, provides the data and you know, logic interface to the blockchain, and those smart contracts are deployed. They have an identifier. They're kind of static. You know, you basically transact through them. Stellar is completely different. It's basically a set of ordered operations. So you have about 11 different operations you can choose from. And you can chain those together to create payment workflows. And once that smart contract is deployed, it's deployed, and once it's fully executed, you know, it finishes. So it doesn't persist. So that's a very different model, but we've integrated that as well. So it's not only for Ethereum, but again, you know, we're just integrating things as you know, as we get requests for them. Michael, hi Michael. How are permissions handled? So we handle it differently on both platforms. So on simbachain.com, you can add group-based permissions, and on a per contract basis and per method basis. So you can have read and write permissions for each of those. And on we use a similar methodology for SCaaS, but we hook it into the particular existing authentication infrastructure. So for example, on Active Directory, we use Active Directory groups. You can create, you know, a group, and then you can associate an Active Directory group to a particular smart contract method. And that would enable those group of users to access that particular method. If they're not in that group, they wouldn't be able to access it. And then from Raneem, SIMBA Chain will be handling the smart contract API endpoint. Okay, so I think I've answered that one. Is there a difference in your support for private? We answered that question, I think, but if you mean support in terms of integration or support in terms of customer support, I'm not sure. Maybe you can clarify that, but I think we answered that question. Is Tendermint supported? Not right now. And then where in QNT in this data flow? Where is QNT? Sorry, I don't understand what's QNT.
I believe he means quant network, and we are still in the. As I've gotten that before, we have gotten that. You know, we have an agreement with quant, and we're in process of working that integration out, but we don't have anything to announce to the public at this very moment, except to say that both organizations are in process of working through that.
Yeah, we have an MOU, and we, you know, to show we're willing to kind of collaborate. We're just looking for that first kind of project to drive that. can we use this on Oracle Cloud? Yeah, so the underlying SCaaS is basically cloud agnostic. We've got a Kubernetes version, which we're going to be using to deploy on the, so anything that runs cloud services, pretty much we can deploy on it. We have, we have Kubernetes, and we've got kind of a Docker a version of this. So yes, it's available on any platform, or we can make it available. This, from my understanding, it is the infrastructure layer with some infrastructure layer. Well, it's not really infrastructure layer. We're kind of one level above the infrastructure. So the infrastructure, we're agnostic to the particular, file storage systems and blockchains that we support. We hook into them and we use those, but we don't manage those at all. We're more sort of on the smart contract level. And things around that, like authentication, authorization, signing, and things like that. That's kind of where our solution kind of fits. Do you help with the setup of permission blockchains in Azure? Yes, we can do that. We have models to support, not only to support the deployment of SCaaS in an environment, but we also have support models to, have our developers work with you in order to kind of bootstrap an application. This is from Mehrab. Is there any chance that I can get a recording of the webinar? That's a question for you, Anjon. Are you making the recording available?
Yeah, and there were a couple of questions earlier as well from others. We are in fact making a recording of it. It is recording successfully. Our aim is to get this out probably on Monday. It will be sent to all the registrants, a link to it, and it will be available on the website. A few of you also asked, is the webinar we had last month in March recorded? Unfortunately, with some audio issues with that one, so we were not able to record it, but this one is being recorded. And it will definitely be made available. And our aim is that all future webinars, barring unforeseen circumstances, will be recorded and made public. And I know many also emailed us over the last couple hours that they weren't able to make it. And so yes, we will be sending recordings out.
Okay, so yeah, so where is the distributed ledger stored? Well, the distributed ledger is stored wherever it's configured to be stored. So in the case of Quorum, that is managed through the marketplace, so you can subscribe to the Azure blockchain, and you can build that's a managed service, so that takes care of that deployment. In the case of the Fabric, then we're relying on existing integrations for that, so it's completely configurable. So SIMBA Chain is designed to connect to the blockchain and take care of the transactions and smart contracts. The blockchain itself, can be configured kind of somewhat independently, really. So that's very flexible. Also, for permissioned blockchain, does the transaction signing still happen on the client side? You mentioned that Azure Key Store. Yeah, so on the Azure version, the choice is up to the application. You can do the signing on the client side if you wish, or you could take advantage of the auto wallet generation that we provide. So, as I explained earlier, a user with an Active Directory account, we can auto generate a wallet, a public-private key, and a public address for that user, and that wallet can be used automatically on the back end to sign those transactions without having to deal with that. It depends on the requirements, and we try and keep that flexible. Anyways, to design a UI to connect it with API methods in SIMBA, to have sort of complete peer. I don't quite understand the question, but if I understand it right, for a proof of concept, we have people using it in SIMBA in various ways. Some companies will start with app.simbachain.com. It's easy to kind of work with. You don't have to, kind of deploy things in an enterprise environment or whatever. And you can build out a smart contract there. You can use our SDKs. On SIMBA Chain, we have a number of SDKs that are available in our resource section. Documentation, sorry, here. So all of these, so we have SDKs for various languages, Java, Python, Node, JavaScript, and .NET. So with respect to that, you can build an application out on app.simbachain.com, use that key methodology that Tommy described, prototype, build your proof of concept for that, demonstrate to a customer, and then once they're ready to kind of engage and go to that next level and make things permissioned, then you can take that smart contract, pull it into your enterprise, and point the SDK to the enterprise version with a few adjustments. You're off and running. So it's pretty flexible. You can do POC in various ways. How to map and add participants in a smart contract flow. There are assets and transact. How to? Oh, I see. In terms of you know, when an asset is transacted from one to another, maybe. I guess I'm unclear about what that means really. You can transact assets. So in the Fabric case, the participants are actually sort of ingrained in the network, if you like, and we're working on that now to integrate those. But in Ethereum, then obviously the the identities of the wallets provide that. I don't know if you have any other comments there, Tommy, on any of these actually. Does the SIMBA chain integrate with R3 Corda? No, not yet, but we have had some requests for that, and we're looking into that. That is actually on our list of things to do. Quant network, yeah, so we answered that question. Are the smart contracts auto created from the workflow so we can modify contracts afterwards if we add some more complex? Yes, so when you see these smart contract, these APIs, these APIs don't actually exist in code. They're also generated from the backend smart contract compiled code essentially. So when you hit this endpoint for this app being identified as belonging to a particular organization, we can look up the these are basically the schema for this is stored, and we auto generate this API, the Swagger API for that. So it's all virtual. So it's auto generated exactly. So when you deploy a new smart contract, the new smart contract links with the old smart contract, and then the new smart contract methods that you defined will are made available. And then okay, so tracking your statement on not being involved in the infrastructure side, but from a protocol networking strategy, some blockchains are chatty. From an enterprise view, path on deployment config from a port node, other than what's out of the box. Yeah, so in terms of the configurability, if I understand the question right, we can reconfigure. I mean, we can configure the SCaaS to point to any blockchain, essentially. So if the question is, if you already have some existing infrastructure in place and you want to connect to that, yes, that can be done. So we can connect to, as long as we can get to the port for that particular blockchain, we can interact with it. I think that was a question, but I'm unclear. Can you write your own client code without using the browser? Yes, the SDKs I showed just now can be used to, these SDKs can be used to integrate into your application. It makes it super easy. They're very simple. You just basically fill in the endpoint, your smart contract, what method you want to talk to, what your payload of the method is in terms of, what parameters there are, and then you can start using it. So it's pretty straightforward. Is it easy to identify the UI which transactions should be private? That's a very interesting question. So right now we don't document the authorization within the Swagger. We only document the methods. The authorization happens, when the method is called and requests are approved or not based on the authorization infrastructure at that point. But that's a very good point. We could indeed, provide groups or something in the documentation. So that's a very good point, actually. And then the last question I have here. Thanks for the webinar. Have a go. Looking forward to the next events. Okay. Stay safe and healthy, and that goes for everybody that joined. And we're a little bit over, and so I guess I'll hand it back to Anjon to wrap up. Thanks for your
Yeah,
time.
thank you all for attending it. Yeah, thank you all for attending. This was a great webinar. Thank you, Tommy and Ian, for your time here. I'm sure our audience here highly appreciates this. Recording will be available. Please don't hesitate to reach out to me or any of us if you have follow-on questions. We hope we answered your questions well and that you found this to be very, very valuable. And we'll see you again next time. So stay safe, everyone. And I believe there should be a 60-second survey at the end of this if you do have time to take it. Just 6 multiple choice questions, 10 seconds each. Thank you so much. Have a great day. Stay safe.